Okay. The term correlation is very much abused. The term correlation is very much abused. But in reality, we tend to use the word correlation when we are trying to find relationship between two continuous variables. My wife keep telling me to sit up straight. Tapi I think when I sit up straight, nampak gemuk. Alright. So we're going to cover today about what is positive, negative bivariate correlation. We have the ratio effects, outliers, regression prediction, and directionality problem. Okay, I'm not going to cover on partial correlation. Partial correlation we tend to cover inside the advanced class, but you are more than welcome to download the slides from the advanced set. Okay, number one, if you're doing correlation, it must be related pairs of data. What I mean by related pair means if you're trying to relate between height and weight, the height and the weight must come from the same person. The height and the weight must come from the same person. If you want to do a Pearson correlation, the data should be interval or ratio in nature. The data should be interval or ratio. Bahasa senang, continuous data. Again, it must be normally distributed and there is a linearity. What is meant by linearity? There is a linear relationship between the variables. Okay, there should be a linear relationship between the variables, and there is homoscedasticity. Homoscedasticity refers to the distribution of data, which I'm going to highlight later. Okay, so these are the syarat-syarat, the prerequisite for Pearson correlation. Okay, so by the way, today we got fantastic green screen effect. You can see belakang tu betul hitam. I can move my pictures anywhere and I will not affect the picture. So you can see here, I can be shifted in the middle there. I'm okay. Reason because Zaki has placed the lights correctly. So that's why the green screen is doing very well today. Okay. Okay. So for the Yerkes adoption law, okay, this one, let's talk about stress. Why are you all always stressed? Because whenever you're stressed, you end up being productive. Okay. Why your lecturer bully you, asking you to do this, to do that, so that you become productive. Kalau we don't do that like that, you are never productive. And when you're not productive, you don't get your thesis done, you don't get your clinical skills to be better. So that's why we always apply stress on you all so that you can become better. But stress do not have a linear relationship. Why do I say that? Okay. Initially, when the stress is normal, okay, not too much, as it goes up, your performance increase, your performance improve. But if there is too much stress, you end up not being able to perform at all. You just give up, don't do anything. You become depressed, you start thinking about committing suicide, and you end up not doing anything, and you lari daripada ward, you lari ke hospital, you nyorok kat gua mana-mana, nak menghilangkan stres. So whenever you have situation like this one is a non-linear. So when you have a non-linear like this, you cannot use Pearson correlation. You can only use Pearson correlation only in linear relationship when it is going up or going down accordingly to the trigger. Okay, so correlation tend to be between the variables x and y. So for example, stress and illness. Okay, So correlation also got parametric analysis and non-parametric analysis. For the parametric analysis is Pearson. For the non-parametric analysis is Spearman or Kendall rank correlation. The weird thing in the Spss, you do all three, Pearson, Spearman, and Kendall, using the same command. Okay. Am I worried? Yes, I'm worried. Right now my screen is changing by itself. I don't know why. Okay, so we already covered that. So examples of Pearson, height and weight. Examples of Spearman, we have pain intensity, like those in orthopedic. They have the visual pain score, VAS. Why they call it VAS? Forgot already. Okay, and work saturation and work output. Okay. Okay, so we'll cover this. Dah sudah. Okay, history. Basically, it was discovered by Sir Francis Galton. So Sir Francis Galton was trying to find the relationship between the height of the fathers and the height of their sons. And he discovered a way to mathematically measure this relationship. He called it the coefficient of correlation. Okay, coefficient. Why correlation? The word is originally co dash relation. Why correlation? Because it's the relationship between the father and the son. But 3 years, 4 years down the road, the secretary misheard him and typed in the word correlation, C-O-R-R, instead of CO dash relation. So then from that on, it became a real word, correlation. Okay. And Pearson was the one who formulated the idea in its most complete form in 1895. R.A. Fisher came up with the geometric formulation. Okay. And that's it. Okay. So that's the story. So why it is called Pearson's correlation, not called Galton's correlation? Lembu punya susu, sapi dapat nak. Yeah. So Pearson stated it as Galton's correlation, but nowadays it is known as Pearson's correlation. This is what they call the Stigler's law. Lembu punya susu, sapi dapat. Okay, so here's an example of correlation between height and weight. Okay, the taller you are, the bigger is your weight. Of course, that thing works for me only till the day I got married. After I got married, that does no longer hold true. My weight has increased. After the day I got married to my wife, my weight was 63 kilogram, 63 kilogram. Now my weight is 106 kilogram. My wife keep hashing on it. She said, when she got married to me, her weight is around 50 plus. Now hers is only 65. Not fair because I from 63 go up to 106. Susah. Janji bini saya cantik lagi. Masih lagi menarik. So this is the R formula. This is how you calculate the R. Again, we are not going to calculate the R manually. This is only for me to torture the undergraduate students and my postgraduate in JKM. So those who took my subject in year 1, in year 2 undergraduate, and in year 1 postgraduate, they have to learn to do this manually. But you all are clinicians, you got no time to do manual. You got no time to do manual. So what you will do, we will teach you to use SPSS. We will teach you to do using SPSS. Okay. All right, let's go to SPSS. So you can see this is how they do it manually. Right now I cannot change the screen. All right. So from this table, we get the T value and then you get the P value. Okay, it does not matter because for us, we are just going to do it using Spss. So what is important is how to interpret. So when you get the correlation value, the value is from 0 until 1. The value of correlation is between 0 until 1. You can also get from -1 to 0. -1. So the range is from -1 to 0, then 0 to 1. Okay. Why? Because 1 shows the biggest relationship. -1 also shows the biggest relationship. Either negative or positive, it shows the direction of relationship. Okay. So last time, whenever I come to this part, okay, I always give the example of the politician. Okay. So, but now cannot use politician. Why? Because their alliances keep changing. Satu hari musuh, satu hari jadi kawan. So susah nak pakai politician. So what was the last time I used? I used Anwar Ibrahim and Mahathir. So I said if Mahathir is on the top, okay, so then Anwar at the bottom. Last time lah. Now cannot. Why? Mahathir and Anwar become same team. Susah. So let's take another example, easier one, Najib. So Najib dengan Mahathir. So Najib dengan Mahathir, the correlation is negative. Why correlation is negative? Bila Mahathir naik, Najib turun. Bila Najib naik, Mahathir turun. So bila Najib naik, Mahathir kena bully. Bila Mahathir naik, Najib kena bully. Dan sekarang ni Perdana Menteri Ismail apa? Lupa. Asyik tukar Perdana Menteri, lupa. Dia Najib okey lah. Alright. So that is negative. What is positive? Rosmah dengan Najib. Rosmah naik, Rosmah naik. Najib naik, Rosmah pun naik. Then there's a strong positive correlation. Alright. So that is how to decide. Okay. So I already mentioned to you the value of R. I already mentioned the value of R is between 0 to 1 ataupun -1 to 0. So if it is 0.8, either negative 0.8 or positive 0.8, the strength of linear relationship is very strong. Okay. 0.6 to 0.8, moderately strong. 0.3 to 0.5 is fair. And anything less than 0.3 is poor. Anything less than 0.3 is poor. Dang. Ada 7 minit lagi. Okay, so these are correlation. You get better students, you end up with better results. Okay. Macam for me, I dah gemuk, BMI tinggi, I have reduced effort tolerance. So nowadays, I can no longer go upstairs very fast. So I always tell myself to pick up this one. Okay. 0.9 is very strong, but it is not 90%. Instead, if you square the value, R square, then you become the coefficient of determination, the portion of variability in one of the variables that can be accounted for by the variability in the second variable. Okay, coefficient of determination. So if you have R of 0.5, okay, R minus 0.5, so the R square becomes 0.25. So therefore, 25% of the variability in the CGPA scores can be accounted for by depression. Okay, so that is the story about that. So here's an example of the baby's birth weight and mother's BMI. So you can see that 20% of the baby's birth weight is determined by the mother's body weight. Okay, this one I'm going to skip. Why skip? Because you're supposed to have your break at 10:30. Okay, ni cerita bomba, cerita api, tak payahlah. Tak penting. Okay, problem with directionality effect because you tend to use cross-section study. So you don't know which one comes first, the chicken or the egg. X come first or the Y come first. Okay? For example, given class attendance and higher grades, is it you got good class attendance, therefore you get higher grades, or you like to come to class because you always get higher grades? Okay, same like violent TV lah. But this one I'm not going to cover. Just take note that there is a way to check whether it is which one. The third variable problem I'm going to skip also. I'm just going to highlight the fact that sometimes you are missing the forest for the trees. The factor that is missing is not being studied. Okay, you're studying class attendance, GPA. Now the problem is motivation. Only those who are motivated will come to class. Now these people don't want to come to university. Why? Why should they enter university? Because it's the gig-based economy. Boleh jadi food panda-nya orang. Okay, so tak nak masuk universiti. So this one again, number of mods and crime rate, basically it is due to the number of population. Lagi ramai orang ada, lagi banyak crime rate berlaku. It's got nothing to do with the mods. Okay, ice cream is due to the weather. Okay, orang panas dia duduk berendam, dia pun banyak makan ice cream, therefore they end up with more drowning cases. But of course nowadays kita drowning cases happen sebab air pasang, hujan lebat, berlaku air pasang dan air akan banyak turun. Last Friday it happened again, but in Sichuan, China, 7 orang mati, 12 orang hilang dan 9 orang cedera. Okay, this is the most important part. How to do correlation in SPSS. So I'm going to show you correlation in SPSS. Doktor lajunya, ya. Sebab nak kasih kau makan. Oops. Is correlation same with association? In terms of the testing, the name of the test is called correlation. The results, we will say whether it is strongly associated or not strongly associated. For example, later when you do the example, you're going to say that you're going to see that the BMI and the baby birth weight is fairly well associated. Okay, so wujud hubungan yang kuat antara berat ibu dengan berat anak. So the word association here refers to the test which is correlation. All right, I'm going to share the first screen. Share. Okay, right now you see my trade secret, how I change all the screen. Okay, I'm going to go to the SPSS. So here's the data set. Okay, I'm going to do correlation. So to do correlation, first we're going to do this legacy dialog, scatter diagram. The demonstration is we're going to show you between the BMI, X, and the baby's birth weight, Y. Okay, so you can see that there is a linear relationship between, okay, so you can see here there's a linear relationship between the mother's BMI and the baby's birth weight. You can see here, the higher the mother's BMI, the higher is the baby's birth weight. The lower is the mother's BMI, the lower is the baby's weight. Okay, you can see that. All right, so there's a linear relationship. I cannot draw the line because I cannot edit the content. What to do? Okay. Next, we are going to run the correlation. To do the correlation, you just click Analyze, Correlate, Bivariate. So analyze, correlate, and bivariate. So you can see here, analyze, correlate, and bivariate. We are trying to relate between the BMI and the baby's birth weight. Okay, you click OK. You get the results. Very simple. The correlation is a positive 0.432. You can see clearly that here, as the value of the weight increases, the value of the baby, as the value of the BMI increases, the value of the baby's weight also increases. So that's why the correlation is positive. Okay. But also you can see that you have redundancy. Okay. So what you need just this one. So 0.432, the p-value is very significant. Yes, there is a strong association. There is a fair association between the baby's birth weight and the mother's BMI. Okay, there's a fair association. So you got strong, you got weak, fair, moderate, strong. 0.432 is fair. So there's a fair association between the mother's BMI and the baby's birth weight. All right. So that is what is meant by. Okay. And that is for correlation. I'm going to quickly jump to linear regression. After that, we can break for makan. I also want to makan again. hungry. All right. So this one correlation will be very fast. Sorry, regression will be very fast. So I'm not going to cover everything about it. Not going to cover all that. Okay. Yeah, I need to change my screen. Okay. Okay, so I'm going to skip quite fast this one. Let's share screen first. Very fast, guarantee one. Why? Sudah lapar. Tak boleh share. How to share? I cannot find my Zoom. Okay, this is my Zoom. I cannot even differentiate the. Okay, I share. Sama je, share tak share sama je. The gambar is same. Okay. Simple linear regression is if your correlation is significant. Kalau correlation adalah significant, then you may want to come up with a formula. To come up with the formula of the relationship, you come up with the what they call simple linear regression. So this simple linear regression is basically trying to come up with a formula y equals a plus bx. So y equals a plus bx. Here in this example, the cholesterol level. So cholesterol level is 5.9 plus 0.058 of the age. Okay, maknanya makin tua makin berlemak. So orang ni sama macam kelapa. Kelapa lagi tua lagi berlemak. Okay, so you nak lemak banyak, you ambil kelapa tua. You nak orang banyak lemak, you kahwin orang tua. Banyak dah lemak. Alright. So here's the example given. I'm not going to worry about that. These are all the examples of the formulation. So why is the, how come they can draw that line? The line is based on LSD. LSD is least square differences. The computer will calculate which line drawn will generate the smallest differences, and that is the line that you get. Okay. Okay, a good line that is minimize the sum of square differences between the points and the line. So I'm not going to cover that. So these are all theory and showing calculation. Okay, so this is how they decide which line is the best. Okay, I'm not going to cover about MIR, not today, not now. So let's look at simple linear regression. Simple linear regression, the analysis is very simple. Okay, I'm going to show you later how it is done. And you will get a table like this. You will get a table like this, simple linear regression, between the risk factor and outcome. So here for cholesterol, you can see that the linear regression is between age and blood cholesterol level, duration exercise and blood cholesterol level, diet, inventory score, and the blood cholesterol level, and socioeconomic index and the blood cholesterol. So you can see these are the factors affecting a person's blood cholesterol. Okay, so when you come up with the y equals a plus bx, basically the computer will generate the best possible line, the best fit line, and A is where the line crosses the y-axis. A is the place where the line crosses the y-axis, and B is the slope of the line. Thus, if you have the value of x, you can predict the value of y. And here are all the formula that you don't have to know. Here are all the formula on how to calculate the linear regression. But here for us today, we are not going to be worried about that, because I'm just going to show you how it is done using SPSS. Okay, using SPSS. So these are all the example. So let's go to the last part of the whole thing, then we can have a break. Punya semangat Dr. Azmi nak break kan? Okay, I'm going to share the screen again, the correct one. Zoom webinar, share screen, screen 1, share. So you can see now it's changing the screen. Now I'm going to get you to show the SPSS one. Okay, so SPSS, for the purpose of the demonstration, I am going to use somebody is asking why is there a black box there? Black box is the controller button for the Zoom. I cannot change it to the other screen because my other two screens are very small. Tak sampai 6 inci. Alright, so click analyze, regression, linear, analyze regression. What is the dependent variable? Here the dependent variable, the outcome of interest is the baby's birth weight. So we're going to take the baby's birth weight, we put it there. What is the independent risk factor of interest? Here we wanted to know the mother's BMI. Okay, this is example only. Okay, after that, make sure the method selection is enter, click OK. And that's it. You already have the y equals a plus bx, where y equals to 1.524 plus 0.053 BMI. Okay, so you have to look at the last table only. You have to look at the last table only to determine the y equals a plus bx. So y equals to a is 1.524 plus b 0.053x, and x is the mother's BMI, and they are both significant. How much does this model contribute to the outcome? 18%. 18%. So R square, you can see there, 18%. 18% of the mother's BMI contribute to towards the baby's birth weight. And with that, I stop here for the correlation and linear regression. I already answered all the questions during the class. So we take a break now, and when I come back, I'll see whether there are any more questions. Okay, thank you, Madam Chairperson.
Thank you, Prof. But I do have one question. Tak apa, nanti I tanya Prof later. Not today. Everyone is eagerly to have that break. So yeah, we can have that break to 10:50, and we hope to resume then with the title of non-parametric tests. All right?
Okay.
See you, everybody.